everyone. This is Sangeetha Margaret from Department of Physics, St.Joseph College of Arts and Science, Cuddalore. And today we are going to talk about bistable multivibrator using Opamp. So here is the circuit diagram of bistable multivibrator. Here we are using five main components. They are the first one is operational amplifier, and the second one is capacitor, and three more resistors we are using. So five components we are using. The main component is operational amplifier. Here you could see from the figure that is our input is given in the inverting terminal, that is minus region, and in the non-inverting terminal we are having our feedback. So from the output voltage through R1 we are taking feedback voltage, and here we are providing the voltage divider biasing, that is R1 and R2. R1 and R2 will produce the voltage divider biasing, and also we are having one more resistor in the inverting terminal, that is R. So both the resistors are connected to the grounded, and in the inverting terminal we used to give trigger pulse, okay, and also we are having VCC supply. So this is the circuit diagram of bistable multivibrator, and here in the point positive voltage, that is VP, I am mentioned here VP. So VP, how do we calculate the voltage at the point VP? So here I have given you the small diagram. So VP will be equal to, as I told you earlier, here we are using voltage divider. So VP equal to R2 divided by R1 plus R2 into V0. Sorry, here V0 is hiding. So into V0. In this way we are calculating the positive voltage. Okay. So we'll see the before that I would like to tell you about bistable multivibrator. So it has two stable states, either in on state or in off state. Okay. No such quasi stable states present here. Okay. So the output voltage can stay at one of its stable states indefinitely, unless or until an external trigger pulse is applied, and an external trigger pulse causes a transition in the output voltage to another stable state, and it can stay at that state indefinitely. So if I am going to give a second pulse, so automatically the output voltage back towards previous state, and it will stay forever. So one trigger pulse causes the multivibrator to flip from one state to another sorry, and the next pulse causes it to the flop back towards original state. Hence we would call it as a flip-flop. Okay. So it can store only one bit of information into its output terminal. Okay. So let us see the working of this bistable multivibrator. First, if I'm not going to give any trigger pulse, that is I'm not going to give any input. You just think of like that. So what will happen? So with the help of this VCC supply, the operational amplifier will produce some of the output voltage. We all know that that voltage would call it as offset voltage. So if I'm not giving any input, but then I'll be get some output, means we would call it as offset voltage with the help of VCC. So this output voltage will be appear in the positive voltage point in the non-inverting terminal. So now you could see now you can understand, though I am not giving any input, okay, input, but then I am getting some output to the output, it is feedback to the non-inverting terminal. So if I am going to compare, if I am going to differentiate positive voltage minus negative voltage, then the differentiate output only will be the operated, and with that help of differential output only I'll be get output. Okay, so here we are having two prominent conditions. The ones, if in case if positive voltage is greater than negative voltage, means my differential voltage will be positive, then my output voltage will have positive saturation voltage. Okay, and if my positive voltage is less than Vn, that is negative voltage, then my differential voltage will be negative, then my output voltage will be equal to minus saturation voltage. So with the help of these two conditions, I'm just going to explain you the output diagram here. Okay, so as you could see, in the triggering pulse means our input pulse. So I'm having this standard line up to T1. This standard line will tell you that there is no input, that is Vn will be equal to 0. So in this situation, if Vn will be equal to 0, only offset voltage is appearing, then I'll be get the positive voltage. So if I'm getting some positive voltage, means Vn will be equal to 0, means what condition would apply? Vp is greater than Vn, because I'm getting some voltage at the positive voltage point, whereas Vn is equal to 0. So in this condition, I'll be having differential voltage is positive, then my output voltage is positive saturation voltage. Okay, so here you could see through apparently you could see that is in the standard line up to T1 we are having positive saturation voltage. Later then, if I am going to give positive trigger pulse, means up T1 at T1 I am giving positive trigger pulse, isn't it? If positive trigger pulse is applied, then my output will be, so the second condition would apply here. So Vp is less than negative voltage, means my differential voltage will be equal to negative, then my output voltage will be equal to minus saturation voltage. So it during the positive trigger pulse, my output comes down, that is to the negative saturation voltage. So it will remain for some time until my second trigger pulse would have to give. So the second is in negative, so negative trigger pulse is given, then I will get the positive saturation voltage. So in this way the experiment repeat. Okay, so from this explanation you could notice one such point, that is the trigger voltage. The trigger voltage is always greater than the voltage divider value, R2 divided by R1 plus R2 into instead of V0 we can put here Vsat, that is saturation voltage, if in this case of positive Vsat. If it is case of negative Vsat, means minus trigger pulse, so greater than equal to R2 divided by R1 plus R2 into minus Vsat. So from these two explanations, what I am telling you is, if I am giving positive trigger pulse, means I'll be get negative saturation value. If I am give negative trigger pulse, means I'll be have positive saturation voltage. So in this way the bistable multivibrator works. Okay, so that's all. Thank you.